standard form. This is where things get a bit busy. This is rearranging equations, and when rearranging equations, you think algebra. A lot of algebra today, and Charlie is a little concerned. Not only is he concerned, but he's also feeling a little heavy after all the trick-or-treating yesterday. So we're rearranging equations, and the reason is there is an equation of a line that you will often see what we call the standard form, and the standard form is just another way of saying y equals mx plus b, but it looks different. Okay. What's true is a, b, and c are just integers, and by integers I mean specifically they're not decimals and they're not fractions. Theoretically they can be, but from our perspective, what we do in this class is they're always integers. Okay. And then the other thing, just for a proper standard form, is whatever's in front of the a, like whatever's in front of the x, sorry, has to be a positive. It's either positive 1 or positive whatever, not a negative number. This can be negative, and this can be negative, but this one's never. Going quickly again, I want to remind you that if I go too quick, you need to take the initiative and stop the tape to make sure you got everything down. And if my explanation's quick, try re-listening. It might help. Okay? Okay, so here's a standard form right here. Standard form of an equation. Again, it doesn't look exactly like that one, but just means that a is 1, b is -1, and c is 3. Looking back to that standard form. So it says identify the y-intercept form of the equation as well as the slope and the y-intercept itself. So it's a big thing, and first I'd like you to write down what I have on the left here. You can see I kind of broke it up into 3 columns. Let's look at the left, the strategy. What are we overall trying to do? Well, we want to get y by itself, because that is the y-intercept form, right? Y is by itself. Here it is. Here's the y-intercept form, and we want it to look like this. Okay? So to do that, we just use opposite operations to end up with the x on the other side of the equation and the just number over on the other side of the equation. Okay? So the steps in this particular case, first write out the original equation. That's what I've got here. And then I'm going to add y to each side. I have this negative y, and I want y to be positive, so I'm going to add y to each side. So it's going to be y on this side, but that's all I've done. X minus y plus 3 plus y, 0 plus y. And then y's cancel. I end up with x plus 3 equals y. Now all I'm doing is I'm going to rewrite this equation. So I have y on the left and the rest on the right. This is the same. What I've done in this step here, from here down to here, is the same as like if I say that 1 plus 1 equals 2 is the same as 2 equals 1 plus 1. It doesn't really matter which way you say it. It's still a true statement, right? So all I've done is flip these. Now I've got it in the right form, and I drew this little 1 here to say that when you have no number in front of the x, that means your slope is 1, not 0. Don't be confused by that, because if it was 0, then you'd have no term here at all, because 0 times anything is 0. It's a 1. Okay? And the y-intercept is 3, the number by itself. So there's my equation, and there's my slope and y-intercept. Same question. We're going to do the same question 3 times, just progressively harder, and hopefully you start to see the patterns and just how to do it. So the strategy is still the same. So you don't have to necessarily rewrite this if you don't want to, because it's the same as the last one. The strategy is to get y by itself using opposite operations. What we're going to do, let me just erase something here. What we're actually going to do in order to do that is rewrite this. This is just the equation again. And then this time I have a positive 3y, so I'm just going to leave this alone. I'm going to leave the 3y over here. I'm going to get rid of the x. Okay? So I'm going to subtract x from each side. So x plus 3y minus 12 minus x, and that means 0 minus x. And that leaves me with 3y minus 12. And what I'm going to do then, I guess I could have written just an intermediate step here that was be 3y minus 12 equals negative x. That'd be sort of the in-between step there. Okay, now I'm adding 12 to each side in this step here. So I end up with 3y equals negative x plus 12. Now here's the kicker. I got to get rid of this 3. So I divide not every side by, don't think of it as every side by 3, though that kind of is what we're doing. You're actually dividing each term. Each term in this expression gets divided by 3. 3y over 3 equals negative x over 3 plus 12 over 3. And I can simplify that so I can get the slope. which leaves me with, these cancel, right? The 3 over 3 is just 1. And so y equals, this simplifies to this. Okay, I'll show you why in a sec. Plus 12 over 3 is 4. 12 divided by 3 is 4. So just, so you're clear on this. Don't forget that minus x is the same as minus 1x. And you can just pull this out here, so that leaves me with the slope. That's all I've done. And the y-intercept is this. So here's the y equals mx plus b form, and here is the y-intercept and slope. Need more time? Please take it. Otherwise, we're going to do just another example. Okay? This one, identify the y-intercept, same thing. Okay? I didn't bother writing the strategy again, but let's look at the steps. First, we write the standard form just as it looks. In this step here, I have this negative 12y, so I'm going to bring the negative over to the other side. So I add 12y to each side. So these cancel out. You end up with 4x plus 8 equals 12y. Now again, first thing I did was flip it. 12y equals 4x plus 8. And then, so I just wanted my y's on the left. And then I divided each term. Remember, a term is just one piece separated by plus or minus signs. Okay, so each of these are terms. One term, one term, one term. Each term by 12. And I end up with y equals 4 over 12x plus 8 over 12. And this last step is I found lowest terms. So 4 over 12, the lowest terms for that would be 1 over 3. And same as 8 over 12, you'd have 2 over 3. Okay? Moving on. Yeah, word problem. This is the last bit of this note. So here we have, make sure we understand the question. Ferd's hot tub. We have the standard form of an equation that models the price for a service call to Ferd's hot tub. Okay, P is the price. H is the number of hours that the repair person works. So, first of all, it wants us to take this equation, put it in this form. Okay, so this, by the way, tells me right away that they're saying that P is my dependent variable and H, hours, is my independent variable, which makes sense because, first of all, I've always told you that time is almost every case it's the independent variable. Time is almost always the x. Okay, so anyway, so it wants us to put it in y-intercept form. So let's just look at that process right here. That's what I have for part A here. Pretty simple. I brought the p over to this side, so minus p plus p. I added p to both sides. Was the first thing that I did, taking this original equation. That left me with 40h plus 200 equals p. Just flipped it around. Same equation written the other way. P equals 40h plus 200. So that tells me my slope and my y-intercept. Okay, so that's that step done. Identify the fixed and variable costs. So fixed is what you pay no matter what. So for this service person to show up, you pay $200, right? So even if H is 0, you still have the price is $200. That's what the fixed is. It's the y-intercept. The variable is the rate that you pay, which is $40 an hour, so 40. Okay? So that's fixed and variable. Pretty easy. Fixed is the y-intercept, variable is the slope, is the short answer. Illustrate the price graphically. So here's the, you see all that on the graph. Label your axes here. So I went up by hours on the x. Remember, hours is the independent. And the price goes up. I just chose a scale of 40s because of this. I chose a scale that would work nicely. So I chose this as my scale. So 40, 80, 120, 160, 200, etc., etc. And so when it comes to graphing it, when H is 0, I start at $200. And after that, you just go up by every hour, it goes up by 40, right? So I should have a point here. It's not perfect graph, of course, as they typically are not. Point here, because every hour, the cost goes up by 40. The last part of the question, again, if you're needing more time, just take it, pause the tape. If the repairman takes 3.5 hours, determine the price. So there's two ways you could do it. One is you could read it off the chart here, which just go to 3.5 hours, go straight up, and that works out to just in between here. So I said 340. Well, I said 340 because I calculated it first. But you can read it off the graph, and there's really, based on the question, there's no reason why you couldn't. But I also solved it algebraically, which just means using the equation, using graphs. So my given is that H is 3.5 hours. What I'm looking for, my required, is the price. The equation I'm going to analyze is the equation we're given, so you just list the equation. Solving it, P equals 40, then H is 3.5, so you put 3.5 there, plus 200, and stating my solution, P equals 340. Okay, so whichever way you did it would be perfectly fine for me. Move on. Actually, that's it. That's it for today's lesson. So again, take time if you need to, stop, re-listen to what you got stuck on, and make sure you practice every single problem that you can, because these take practice.